Welcome to homework.
In this question, we have a monoatomic gas that is being used for a certain heat engine that utilizes this cycle. Okay, there are two parts in the question. We want to find out the efficiency and compare this efficiency to the efficiency of the Carnot engine. Okay. All right. So part A. Okay. Uh, we know that efficiency, okay, is equal to W divided by QH. Okay, so you need to identify which of the four steps you have QH. So QH is when there's heat input. Okay, so that's usually during the rise of temperature in the system. And so when the heat is input. Okay, so and then we also take note that the ideal gas. Okay, so we have PV equals to nRT. Okay, so the product of PV tells the temperature of the gas. Okay. Okay, so if you look at A to B is there's a drop in the product of PV, so there's a drop in temperature. B to C is increase in temperature, so you have QH. C to D is also an increase in temperature because of the increase in product of PV, so you have also QH. And D to A is a drop in temperature because the product of PV decreases. So B to C and C to D is the time where you have QH. Okay, so the QH of the process is equal to Q from B to C plus the Q for C to D. Okay, so this is equal to B to C is an isochoric process, so you have NCV TC minus TB, and then for QC, for process C to D, is an isobaric process, so the Q is NCP TD minus TC. Okay, so I utilize these two formula. Isochoric process, you have Q equals to N CV delta T. Isobaric, okay, at constant pressure. So you use a molar heat capacity at constant pressure. Okay, right. And then we have our, because this is monoatomic, okay, Cv equals to 3 over 2 R, Cp equals to 5 over 2 R. Okay, so you have 3 over 2 and R, Tc minus Tb plus 5 over 2 and R, Td minus Tc. Okay, so and then using ideal gas equation, okay, nRTC is 3P naught times V naught is the product of PV using ideal gas equation. Okay, then nRTB is P naught V naught. Okay, and then you do the same thing for the nRTD. nRTD will be 6P naught V naught, and nRTC will be 3P naught V naught. Okay, so in the end, we get the answer in terms of P naught V naught, which is very nice. Okay, we have 3 P naught V naught plus 7.5 P naught V naught, and we get 10.5 P naught V naught. Okay, this is our QH, and then our W. Okay, the W is the area under PV diagram, or it's actually the area of the rectangle. Area of rectangle. Okay, so if you look at the area of rectangle, you can calculate that. So you have V naught as the width, the length is 2P naught, so it's 2P naught V naught. Okay, the efficiency will just be W divided by QH, 2P naught V naught divided by, this is the modulus, okay, yeah, just in case. Yeah, and then QH is 10.5 P naught V naught. The P naught V naught cancels out. You get 0.190. Okay, so this is how you calculate the efficiency of the heat engine. Okay, then in part B, we want to calculate the efficiency of, we want to compare this efficiency in part A to the efficiency of Carnot engine with the TL and TH in this for the heat engine. So okay, so we note that E Carnot is equal to 1 minus TL over TH. Okay, then just now from the ideal gas equation, okay, PV is proportional to T. Okay, so TL will be the one with the lowest product of PV. Okay, so TL is related to P naught V naught, and then TH is related to 6 P naught V naught. Okay, so E Carnot, okay, is going to be 1 minus P naught V naught divided by 6 P naught V naught. Okay, you get 5 over 6, which is equal to 0.833. And so the E, so the ratio that we want to calculate in this question in part B is E of the engine divided by E of the Carnot engine. Okay, so we get 0.190 divided by 0.833. Calculate this, you get 0.229. Okay, so this is the answer for part B, and that's all for this question.